We're now going to go through the Module 2 document that is at the beginning of Module 2 in Moodle and talk about how to find all of these probabilities. So, in this first one, our example is rolling 2 die. The sample space, and I actually probably don't have enough room here. Whoops, sorry about that. The sample space would be what could happen on the first die and what could happen on the second die. So I could get a 1 and a 1, a 1 and a 2, a 1 and a 3, 1 and a 4, 1 and a 5, let me actually go down with this. And the same thing, 2 and a 1, 2 and a 2. And so to answer the second question, there are 36. And the reason there are 36 items in the sample space is because there are 6 ways that the first die can happen and 6 ways that the second die can happen. And that gives you 36 possible outcomes. If you roll an odd number on either die, list the outcomes and then find the probability. So an odd number on either die would be all of the 1s, let's see, 1 and a 1, 2, 3, all of the 3s for the first die, and all of the 5s for the first die. And it's always best to do it in some kind of simulated order to make sure that you don't miss anything. And then that would be all of the odds on the first die. All of the odds on the second die that I don't have accounted for yet would be 2, 1, 2, 3, 2, 5, 4, 1, 4, 3, 4, 5, and 6, 1, 6, 3, and 6, 5. So 3, 6, 9, 12, 15, 18, 21, 24, 27 outcomes. So the probability would be 27 out of 36, which reduces to 3/4 or 0.75. For number 4, the event B is rolling a number greater than 4 on the second die. So all the ones greater than 4 on the second die would be 1, 5, and 1, 6, 2, 5, and 2, 6, 3, 5, and 3, 6, 4, 5, and 4, 6, 5, 5, and 5, 6, 6, 5, and 6, 6, and so 2, 4, 6, 8, 10, 12. So there are 12 outcomes, and the probability would be 12 out of 36, or 1/3, or 0.3 repeating. The next one, North Carolina license plates, use the fundamental counting principle. So, how many different North Carolina license plates are possible? 3 letters. So we know there's 26 letters in the alphabet. So that would be 26 times 25 times 24 for my letters. And then 4 digits. So that would be times 10 times 9 times 8 times 7. So if we do 26 times 25 times 24 times 10 times 9 times 8 times 7, we get 78624 78,624,000. If O's and I's and zeros and ones are omitted, then how many possible do we have? Well, if we omit 2 of the letters, then we start out with 24, 23, and 22. If we eliminate 2 of the digits, now we have 8, 7, 6, and 5. And that gives us 20,401,920. Nope. And I have totally messed that up. So let's go back. Because what I just did was actually the answers to 3 and 4. So let me move those down. Because if no repetitions, then once I use a letter, I can't use it again. So that would be 26 times 25 times 24 times 10, 9, 8, 7, 78, 624 versus 24, 23, 22, 8, 7, 6, 5. And the mistake I made is that in problems 1 and 2, it doesn't matter if letters repeat themselves. So we actually have 26 times 26 times 26 times 10 times 10 times 10 times 10. So that's 26 to the 4th power. 26 to the 3rd power. Times 10 to the 4th power. So 175,760,000. And then if I omit 2 of the letters and 2 of the numbers, then I do 24 to the 3rd power times 8 to the 4th power. And that is, whoops, in the wrong place. 566 23104. So, definitely a difference whenever you can't have repeats. Or, excuse me, when you can have repeats versus when you can't have repeats. Going on to page 2. There are 25 students taking trig, so I'm going to put 25 up here because I know that the total box has to add to 25. 14 of them plan to register for calculus. 12 are math majors. So I know this whole circle has got to be 14 for calculus. I know the whole circle for math majors has got to be 12. And it tells me 5 of the math majors plan to take calculus. So I know that's the intersection. So then I have to do 14 minus 5 and get 9 that just take calculus, but are not math majors. 12 minus 5 is 7. So there are 7 that are math majors that aren't going to take calculus. That gives me 21. So there are 4 students that are not math majors and not taking calculus. So how many of the math majors do not plan to take calculus next semester? That would be 7. How many of the trig students are not math majors and do not plan to take calculus? That would be the 4. How many of the students are math majors who are not planning to take calculus? Which is the same question as 1, which is 7. Then for section 3.3, how many adults were in this survey? So we need to add up each of the 3 frequencies. 347 plus 281 plus 259 plus 139 plus 44. So that's 1,070. The probability that a randomly selected adult gave a grade of A. So that would be 44 out of the 1,070, which is 0.0411. The probability a randomly selected adult gave a grade of F. So that would be 139 out of 1070. Which would be 0.1299. Are the grades A and F mutually exclusive? Going back to the definition that mutually exclusive is they cannot happen at the same time, then you would say yes. The adults gave one answer and there is no intersection between A and F. So find the probability that a randomly selected adult gave a grade of A and F. That would be 0. Find the probability that a randomly selected adult gave a grade of A or F. So if we go back and look at the A or F, that would be the 139 plus the 44. Out of the 1070. And we can just add the 2 because there is no intersection, so there's nothing to divide out. So that's 183 divided by 1070, which is 0.171. For the next example, how many students are in the survey? That would be 200. The probability of a student attending the study sessions. So that's 120 out of 200. And you can leave these as fractions or decimals. I think my lab stats will tell you to leave it as a decimal and how many decimal places to use. But I don't care which way you leave it for me. So that would be 0.6. The probability of a student improving his grade would be 105 out of 200. Which is 0.525. Are the events attending the study session and improving the grade mutually exclusive? No. Because a student can do both. There is an intersection. And the intersection of attended and improve their grades is 80. The probability of a student attending the study session and improving his or her grade, well, that's the intersection, so that would be 80 out of 200, which is 0.4. The probability of a student attending the study sessions or improving her grade, his or her grade. So this is attended the study sessions. That's improved the grade. So I could do 120 out of 200 plus 105 out of 200 minus 80 out of 200. Which gives me 145 out of 200, which is 0.725. Or you could just add the 25, the 80, and the 40. Find the probability of a student attending the study sessions and not improving his or her grade. That would be the 40 out of 200, which would be 0.2. Find the probability of a student neither attending the study sessions, so they did not attend the study sessions, and they did not improve their grade. So that is 55 out of 200, which is 0.275. Is it unusual for a student to attend the study session and his or her grade not improve? So if they attended the session but did not improve, that would be the 0.2. The probability of attending and not improving is 0.2. This is not less than 0.05. So remember, for something to be unusual, the probability it happens has to be less than 0.05. Now we're going to look at the deck of cards, and I went ahead and gave you the picture here of what the deck of cards looks like. Are the events drawing a red card and a club mutually exclusive? Well, that would be yes, because clubs are not red. Find the probability of drawing a red card and a club. So that would be 0. We're talking about one card here. Find the probability of drawing a red card or a club. Well, that would be there are 26 red cards plus 13 clubs out of the 52 cards. So that's 39 out of the 52, which would be 0.75. Are the events drawing a red card and a heart mutually exclusive? That would be no, because hearts are red cards. So if they can be both, then they're not mutually exclusive. Find the probability of drawing a red card and a heart. There are 13 cards that are red and hearts. So that's 0.25. Find the probability of drawing a red card or a heart. That would be 26 out of 52, or 0.5. Find the probability of drawing a diamond or a queen. So because this is or, and we're talking about one card, I have 13 diamonds, plus I have 4 queens, but I have one that is a queen of diamonds, so I have to subtract out the intersection. So that gives me 16 out of 52, or 0.3077. Find the probability of drawing the king of hearts given the card is a heart. So now instead of 52 cards, we only have 13. And out of those 13, only one is the king of hearts. So that's 0.077. Find the probability of drawing a 6 given that the card is a number card. Well, remember there I told you that aces are faces. So there are 4 face cards per suit. So there are 16 face cards. And therefore, there are 36 number cards. So out of those 36 number cards, there are 4 sixes. And that gives you a probability of 0.111. So going back to the same example we used before, we know there are 200 students. The grade improved, that was the 120 out of 200, which was 0.6. Knowing that the student attended the sessions. So now we're only talking about 120 students. The probability their grade improved is 80 out of 120. Which is 0.6 repeating. Find the probability that a student's grade did not improve given that he or she did not attend the sessions. So that means that now I'm only talking about the 80 people that did not attend the sessions. Out of those 80, 55 did not improve their grades, so that's 0.6875. Should the instructor recommend the sessions to future students, why or why not? And I'm going to leave that question for you to decide, but base your answer off of probability. Looking at whether it helps to attend the session to improve your grade versus not attending the session and improving your grade. So that is a question that you can answer on your own. Going back to a deck of cards. Again, we're going to draw one card. So the probability of drawing a black card would be 26 out of 52, or 0.5. The probability of drawing a club would be 13 out of 52, or 0.25. The probability of drawing a 5 would be 4 out of 52, or 0.077. And the probability of drawing a face card would be 16 out of 52, or 0.3077. Now we're going to look at drawing 2 cards without replacement. So the probability that both cards drawn are black, well, there are 26 of the 52 cards for the first one. And if you don't put that back, then there are 25 out of the 51 cards that are black for the second one. So 26 out of 52 times 25 out of 51 gives you 0.2451. The probability both the cards drawn are clubs, so that would be 13 out of 52 times 12 out of 51. Which would be 0.0588. Probability of drawing a 5 given that the first card drawn was a 2. Well, given that the first card drawn was a 2, means there are only 51 cards left, and there are still 4 that are 5s. So that's 0.0784. Find the probability both the cards drawn are face cards. So that would be 16 out of 52 times 15 out of 51. Which is 0.0905. So let's look at the difference of what happens when you put the card back. So both are black. This time would be 26 out of 52 times 26 out of 52. Which is 0.25. Probability both the cards are clubs, so that would be 13 out of 52 times 13 out of 52. Which is 0.0625. Find the probability of drawing a 5 given that the first card is a 2. It doesn't matter what the first card is. So now we're just 4 out of 52, which is 0.077. Find the probability that both the cards drawn are face cards. So that's 16 out of 52. Put it back. You still have 16 out of 52. And that gives you 0.0947. And then you can compare, looking at those two differences, what happens with replacement versus without replacement. Obviously, with replacement in all the scenarios, the probability for the first two was higher. For the last one was higher. For the third one was not as high because I had more cards I was drawing from. And these last questions, well, next to the last questions. The chance of rain for the next 3 days is 70% for each day. Find the probability it will rain all 3 days. So that would be the first day it rains times the second day it rains times the third day it rains. So 0.7 raised to the third power is 0.343. The probability will not rain any of the 3 days. Well, that means it doesn't rain the first day, it doesn't rain the second day, and it doesn't rain the third day, which is 0.027. A major airline company did a study of 1,000 randomly selected flights. Data showed 760 of them arrived on time. If 2 flights are randomly selected, what's the probability that both are on time? So that would be 769 out of 1,000 times 768 out of 999. Because I took one of the flights out. So that would be like without replacement on the cards, and that's 0.5912. If 2 flights are randomly selected, what's the probability both are not on time? So if 769 of them are on time, then 231 of them are not on time. So that would be 231 out of 1,000 times 230 out of 999. Which gives you 0.0532. And the last section in chapter 3, section 3.4. For dinner, you plan on choosing an appetizer, a meal, a drink, and a dessert. So there are 5 appetizers, 8 meals, 10 drinks, and 6 desserts. So this would be the fundamental counting principle. 5 times 8 times 10 times 6 gives you 2,400 possibility combinations for dinner. The access code to a securities house system consists of 5 digits. How many different codes are available if the first digit cannot be 0 and the arrangement of 5 fives is excluded? So let's look at, if the first one can't be 0, that means there's 9 digits for the first number, then 10, then 10, then 10, then 10. So that gives us 90,000 combinations. But 5 fives is excluded, so I'm going to subtract 1. So that's 89,999 possibilities. If a couple plans to have 9 children, how many gender sequences are possible? Well, there's 2 genders for the first child, 2 for the second, 2, 2, 2, 2, 3, 4, 5, 6, 7, 8, 9. So that's 2 to the 9th power. So there are 512 different combinations. You've been called to be on a jury. When you arrive, including yourself, there are 9 men and 11 women. How many ways can the jury of 12 be selected from a pool of 20 people? So there are 20 people. We want to know how many combinations of 12. So that's 125,970. How many ways can the 5 numbers be selected from the 56 numbers for the white balls? So you have 56 numbers. And you are selecting 5. $3,819,816. And that concludes everything on the practice for Chapter 3.